Welcome to Daily Papers.
The podcast where we break down fascinating new research papers. Today, we're talking about the safety of large language models, or LLMs. AIs like ChatGPT and Gemini.
Exactly. We all want these powerful tools to be safe and helpful, and not, for example, teach someone how to do something dangerous. The companies that build them spend a lot of time and effort on safety training to prevent this.
And a big part of that is testing. They have these huge lists of harmful questions called benchmarks that they throw at the AI to see if it refuses to answer. Questions like, how do I build a weapon? Or give me a recipe for a dangerous chemical.
If the AI says, "I'm sorry, I can't help with that," it passes the test. If it gives you the instructions, it fails. Simple enough, right?
Well, today's paper asks a really important question. What if the test is too simple? What if the AI has only learned to recognize the most obvious, straightforward phrasing of a harmful question?
This paper is called Single Canonical Prompts Underestimate LLM Safety's Surface Form Sensitivity. And that title is a bit of a mouthful, so let's break it down.
Let's start with canonical prompt. That just means the standard, most direct way of asking something. So, how do you hotwire a car is the canonical prompt.
But what about the surface form? That's just the specific words you use. You could ask the same thing in many different ways. You could paraphrase it like, explain the process of starting a car without a key, or you could translate it into another language and back. The meaning, the intent, is the same, but the surface form is different.
And that's the whole idea of this paper. Does changing the surface form of a harmful question while keeping the intent the same trick the AI's safety filters?
To find out, the researchers ran a pretty clever experiment. They started with 370 harmful prompts, the canonical versions.
Then, for each of those harmful prompts, they created 4 new versions, or 4 new surface forms. First, they paraphrased it by machine translating it from English to another language and then back to English. This keeps the meaning but messes with the wording.
Second, they translated the prompt directly into Chinese. Third, they did something called code switching, where they programmatically mixed Chinese nouns into English sentences.
Fourth, they used what they call indirect framing. So instead of a direct command, they'd rephrase it as a hypothetical question, like asking the AI to write a scene for a movie.
So now, for every one harmful idea, they had 5 different ways of asking it, the original and 4 reformulations. They then gave all of these prompts to 5 different state-of-the-art LLMs.
And the results were pretty startling. The paper finds that testing with only the original canonical prompt makes these AIs look much safer than they actually are.
A lot of the time, a model would correctly refuse the original English prompt, but then when it got the translated version or the paraphrased version, it would give a harmful answer. It failed the safety test.
The numbers are really interesting. Depending on the model, between 5 and 13% of prompts that were considered safe with the original wording became unsafe when they were rephrased.
So the original test missed those vulnerabilities completely, and the researchers have a term for this. They looked at the union of unsafe outcomes. That just means if any of the 5 versions of a prompt got a harmful answer, they counted it as a failure for that core idea.
And when you look at it that way, the picture gets much worse. The total number of safety failures they found across all 5 phrasings was significantly higher than for any single phrasing. In fact, for most models, the original canonical prompt only uncovered about half of the vulnerabilities that the 5 versions found together.
That's a huge gap. It's like checking if a door is locked by only jiggling the handle, but not checking if the window next to it is wide open.
And here's another fascinating twist. The researchers wondered if this was just a safety problem or if it was a sign of a more general instability in these models. So they ran the same experiment with a set of perfectly benign, safe prompts.
These were questions the AI should answer, and they found that rephrasing these harmless prompts sometimes caused the AI to refuse to answer them. It would say, "I can't help with that," to a perfectly normal request.
So it's not just a one-way street where rephrasing makes things less safe. It seems to cause what the paper calls bidirectional instability. The models just get a bit flaky and unpredictable when you move away from standard phrasing. They fail on harmful prompts they should refuse, and they refuse harmless prompts they should answer.
So what's the big takeaway here? The authors argue that our current method of testing AI safety is too optimistic. A benchmark that only uses one version of a prompt is going to miss a lot.
Right, it gives us a false sense of security. To get a true picture of a model's robustness, you have to test it with a whole distribution of surface forms, many different ways of asking the same thing.
The paper suggests that to be confident a model is safe, you should probably test at least 3 different meaning-preserving versions of a harmful prompt to find about 85% of the vulnerabilities they identified.
Ultimately, this study is a great reminder that measuring these incredibly complex systems is really hard. It shows that the way we talk to AI, the specific words we choose, can have a huge impact on its behavior in ways that we're only just beginning to understand.
It's a call for more robust and realistic testing, so we can get a clearer picture of how safe these AI models actually are before we rely on them even more.